Good day, students. Now consider the geometric applications of the derivative. The geometric applications, the geometric applications of the derivative. Yunazeritis terminin hendasi tatbikleri in Russian geometrические приложения производной. First consider the subtopic named the geometric meaning of the derivative. The geometric meaning of the derivative. This meaning has the following formula: f prime at x sub 0 is equal to tangent alpha and is equal to k. Where x sub 0 is the abscissa of the tangency point, of the contact point, of the contact or tangency point. Contact point or tangent point, it is in Azeri toxunma noktası, in Russian точка касания. Contact tangency point. Toxunma касание. Then alpha is the slope angle, of the tangent at the point with given abscissa x sub 0. Here slope angle is in Azeritis meyil bucağı. In Russian it is угол наклона. Angle, угол, slope, наклон. Угол наклона. Here tangent is in Azeri it is toxunan, in Russian касательная. Toxunan, касательная. K. K is the slope or gradient is the gradient is the slope or gradient or angular coefficient or the tangent equation y equals kx plus b. Here slope is naklon. In Russian naklon, in Azeri meyl naklon. Gradient, in Azeri gradient, in Russian gradient. Angular coefficient, in Azeri bucaq əmsalı. In Russian угловой коэффициент. Угловой коэффициент. Next topic is the tangent equation. The equation of tangent. The equation of tangent. Equation of the tangent. Of a tangent. Y minus y sub 0 equals k multiplied by x minus x sub 0. Here tangent in Azeri is toxunan, in Russian касательная, and it is in Azeri toxunan tənliyi, in Russian уравнение касательной. Y minus y sub 0 equals k multiplied by x minus x sub 0. Where x and y are the variables. X sub 0 is the abscissa of the tangent point, y sub 0 is the ordinate of the tangent point. Which is defined by the following formula. Y sub 0 is f of x sub 0. Y sub 0 is defined by this formula. And finally, k is the slope of the tangent equation, which is defined by the following formula. K is y prime, f prime f prime at x sub 0. It is equation of a tangent. Then construct the graph of a given function and its tangent. But it is a tangent point. Tangent is straight line. Straight line. Straight line. Tangent. Graph of function. Graph of function. Graph of function. Equation of the given function is y equals f of x, and the equation of the tangent is y equals kx plus b. It is slope angle alpha, and it is abscissa of tangent point, and it is ordinate of tangent point. Yes, tangent point. Tangent is straight line. Now consider the example on geometric application of the derivative. Find the slope angle and the equation of the tangent to the graph of the function f of x equals minus natural logarithm of x at the point with the abscissa x sub 0 is unit. Solution. First find the slope angle of the given function. For this we must find the derivative of the given function. F prime of x is minus natural logarithm of x prime. Here negative sign can be taken out of the derivative symbol, minus natural logarithm of x prime, and it is derivative of natural simple natural function. Natural logarithm function is simple 1 over x equals 1 minus 1 over x. Then x, and then calculate the value of the derivative at the point x equals x sub 0 equals unit. F prime at unit, at 1 equals, we must substitute 1 instead of x. Minus 1 over 1 is minus 1. And according to the geometric meaning of the derivative, it is tangent alpha. That is tangent alpha is minus 1. If tangent alpha equals minus 1, then alpha itself is equal to 135 degrees. It is slope angle of our tangent. It is slope angle. slope angle. Then find the equation of the tangent. But also according to the geometric meaning of the derivative, k is equal to the value of the derivative at the given abscissa. K is also is minus 1. K is minus 1. Minus 1. Then find the value of function at the given abscissa. That is, find y sub 0, y sub 0, y sub 0, y sub 0 is f at x sub 0, that is f at unit, and f at unit is minus natural logarithm of 1, but natural logarithm of 1 is 0, that is, it is 0. Y sub 0 is 0, 0. And according to condition, x sub x is also 0. Then remember the tangent of equation of the tangent. Y equals y minus y prime y sub 0 is equals k multiplied by x minus x sub 0. And here x and y are the variables, but x sub 0, y sub 0, k are the constant values. And here we must substitute 1 instead of x sub 0, k minus 1 instead of k, and 0 instead of y sub 0. Y minus 0 equals minus 1 multiplied x minus 1. That is y equals 1 minus x. It is equation of the tangent. Equation of the tangent. Equation of tangent. And then verify the equation of tangent and its slope angle. For this, construct the graph of function and its tangent. Now construct the graph of the given function and its tangent. At the given point. It is the graph of our function y equals minus natural logarithm of x, and it is its tangent at the point 1, and its equation is y equals 1 minus x. Now consider the physical or mechanical applications of the derivative. derivative. The physical or mechanical mechanic meaning of the derivative. Physical mechanic meaning of the derivative. The derivative, the value derivative at the given point is the speed of the function variance. If that is f prime at x sub 0 is the speed, and also the second derivative of the given function is the acceleration of the function variance at this point. Variance f2 prime of x sub 0 is acceleration. Speed is in Azeri sürat, in Russian скорость. Acceleration in Azeri it is tacir, in Russian it is ускорение. This speed is acceleration. Acceleration. Let's continue. Then consider the next topic, named the investigation of a function with help of the derivatives. The investigation of a function with the help of the derivatives. First, consider the differential indications of the increase and decrease function of a function. The differential, it is first subtopic. The differential indications indication of the increase and decrease of a function First point, if derivative is positive, then function increases. But if derivative is negative, then it means the function is decreasing. Increase. And if first derivative is negative, then we have decrease of a function. Then give the maximum and minimum of the given function. The maximum and the minimum, the maximum and the minimum of the given function. First give the concept of the critical point. The critical point of the given function is such a point at which the first derivative of this function is zero or doesn't exist. We can write the critical point. Critical point in other it is böhran noktası. And in other it is, in Russian it is критическая точка. Критическая точка. The critical point is such a point at which the derivative of the function is zero or doesn't exist. Then continue. Now consider the sufficient conditions of the maximum and minimum existence, right? The sufficient conditions of the maximum and minimum of the given function. Sufficient in other it is kafi or yeterli. In Russian достаточно. Kafi şartlar достаточно условия. Open first point. If in the passing through the critical point in the real axis, from left to the right, the derivative of the given function change on sign from plus to minus, then this critical point is the maximum point. If the sign of derivative is changed from plus to minus, sorry, from plus to minus, then the critical point is the maximum point. Then maximum point. Maximum point is azaritis maximum noktası in Russian точка максимума. But if in the passing through the critical point in the real axis from the left to the right, the sign of derivative is changed from minus to plus, then we have then the given critical point is also the minimum point. Now from minus to plus, then we have minimum point. But if in the passing through given critical point in real axis from the left to the right, the sign of derivative isn't changed, then it means the critical point isn't extreme point. If from plus to plus, or from minus to minus, then function has no extreme point. Extremum is the common name of the maximum and minimum. Maximum and minimum together are named extremum. Then use these sufficient conditions of the maximum and minimum existence for the investigation of the given function for increase and decrease and maximum and minimum. Continue the first point of the investigation of the given function with the help of the derivatives. Open the first Roman point. Investigation of the given function, with the help of the first derivative here the sufficient first here the possible critical points are found. Then the found critical points are marked in the real axis, then separate whole real axis into intervals by indicated critical points, and then find the signs of the derivative in each interval, and then use the sufficient conditions of the maximum and minimum points, existence. Consider the following example. Investigate. Investigate the given function. For the increase and the decrease and the maximum and the minimum points, with the help of the first derivative. Now consider function here. Then choose the function for this example. Now write the condition of the given function. F of x is equal to 4x to 5 plus 5x to 4 minus 40x cubed and minus 30. Solution. First find the derivative of the given function, and then equalize the expression of derivative to 0, and thereby we can find the critical points themselves. F prime of x is 20x to 4 plus 20x cubed minus 120x squared is equal to 0. Then we can take 20x squared out of the parentheses, 20x squared multiplied by x squared plus x minus 6 is equal to 0. Then find the rules of the obtained equation. X first is 0, x second is 2, and x third is minus 3. Are the critical points. critical points. Then continue. Then continue. Now construct the real axis and mark the obtained critical points in this real axis. Zero, 2, and -3. Then separate the real axis into the intervals by these critical points. Further, define the sign of the derivative in each interval. We can take here, for example, 10. We must take only the interior points, interior comfortable points. If take 10 and substitute 10 instead of x, we have 100 plus 10 is 110 minus 6 is 104. It is positive, and this factor is positive always. Positive. Then we can take here 1. If substitute 1, we obtain the negative value. Then here we can substitute, for example, -1 instead of x, the expression of derivative. 1 minus 1 is 0, minus 6 is negative. And from the left hand we can take, for example, -10 for comfortable case, and it is if substitute -10 instead of x, we will obtain 100 minus 10 is 90 minus 6 is 84 is positive. Here our function increases because derivative positive. Here decreases because derivative is negative. Here also is our function is decreasing because derivative is negative, and in the right interval our function is increasing function because derivative is positive. But also according to the sufficient condition of the maximum and minimum existence, if in the passing through critical point from the left to the right, the sign of derivative is changed from plus to minus, then this critical point is the maximum point. Here we have maximum. If the sign of derivative is changed from minus to plus, it means here we have minimum. But if the sign of derivative is changed from minus, that is, the sign of derivative is not changed, then we have no extreme. Then write the interval of increase and decrease. X belongs to from minus equal to -3, union interval from 2 to plus infinity, R, the decrease, increase intervals. For x, x belongs to interval -3 to 0, union from 0 to 2, are the decrease intervals. Then x is minus 3 is the maximum point. Maximum point. X is the minimum point. Is the minimum point. Minimum point. X is 0. Isn't extreme point. Isn't extreme point. Extreme point. Then write the homework. Finally, please rewrite your homework. Solve these examples at home. At home, please. Goodbye, students. Good luck.